And the thing is that we have to find the electric field at some point P, which is nothing but, you can say, this is a perpendicular bisector position, and as well as that can be treated as a broad on side positions. Now when you have to find the electric field at point P for this particular positive charge, and you know the dipole directions is from negative to positive, and this distance is L, and this distance is also L. So now the thing is that this particular distance where you have to find the electric field, that is R. Now what will happen? You have to find the electric field at that particular point. Since this is a positive charge, then what will happen? Due to this positive, what should be the directions of electric field? The directions of electric field is, because they are repelled, okay, and for this charge direction of electric field কোন দিকে হবে? Opposite. That means this is the electric field for this negative. Okay, so now the thing is this, that's very good, and the distance is nothing but r square plus l square, and this is also r square plus l square. Now the directions of positive negative electric field is directions, and the positive electric field in that particular directions. So if we find the corresponding resultant, so you have to make a parallelogram, and that is the corresponding resultant, that is E. And you know that if we take this angle as a theta, and this is also angle theta, then that is nothing but, you can say, 2 theta. So that means what should be the electric field? That is nothing but E plus square E minus square plus 2E plus into E minus into the cos 2 theta. That is the resultant electric field. So what we find, that what should be the E plus? The electric field of E plus is nothing but, we can say, 1 by 4 pi epsilon naught, and the charge are Q, and for this is nothing but r square plus s square, because that is a root of r. So if you make it whole square, that is r square plus l square, and of course is along, if you named as say d, so along bd. And what should be the E minus? That is also same, because the distance is, and this is along, you can say, if we consider A, this is B, this is along B. Clear? So what we can find, with E plus is equals to E minus, so the electric field can be written as, if we put E plus should be equals to E minus, then it should be E plus whole square 1 plus, this is a cos 2 theta. That is nothing but electric field. So what we know, 1 plus cos 3 theta, the formula is 2 cos square theta. So 2 E plus whole square into 2 cos square theta, that is the formula. 1 plus cos 2 theta can be written as 2 cos square theta. Now if we make out of root, then this is 2e plus and cos theta, and we know the value of E plus, and what is the value of cos theta? From that diagram, if we consider this particular diagram, say this is O, if we consider triangle APO, so if we find the cos theta, the value of cos theta is L, but that is L square plus R square. So you can just put the value of E and cos theta in that particular equations. That means E is nothing but 1 by 4 pi epsilon naught, this is Q by R square plus L square, and cos theta is nothing but L by L square plus R square. So if you can solve it, then what you can get, the upper portion, that means 2QL is nothing but P, because we know the dipole moment can be written as Q is the charge and the distance between these two is L. So you can write P, and the bottom is nothing but r square plus l square 3 by 2, because that is half, and that is r square plus l by 2. So we can take the same case, that if you can say the value of L is much less than r, that means the dipole is short, then you can say L square can be, you can say, neglected compared to r square. So what you can write, that E is equals to P. If you neglect this, you can say L square, then that should be 4 pi epsilon naught r cube. So you should remember the thing, that when we are finding the electric field as in, you can say, end on position, you can say in broaden positions, then the electric field is E equals to P by 4 pi epsilon naught r cube. From that, what we can find, that electric field is proportional to 1 by r cube, that we can find from that. So I think, so what we can find, that E of this is nothing but, you can say that is equatorial, and if we say this is axial positions is nothing 2p by 4 pi epsilon naught r cube. So what we can find, that E of axial can be written as 2 into equatorial. You can write like that. E of axial can be written as 2 into equatorial. So the thing is that, that is the I think it is clearly understandable. এটা বোঝা গেছে?
Yes.
Okay. So now যে জিনিসটা you should now we are finding the electric field due to dipole at an axial position, and as well as you are find it at the Bourdon or equilateral positions. Now, if we want to find the electric field intensity at any point, that means if we want to find the electric field, you can say, intensity at, you can say, any point, at any point due to, you can say, due to a short electric dipole, that means we have to find the electric field intensity at any point due to short electric dipole. Now if you want to find that, that means what will happen, you just remember the thing, that that is the corresponding electric dipole. So you can say that is a minus q and that is a plus q, that is the corresponding, you can say that is the electric dipole. And of course this is the directions of the electric dipole. Now the thing is that, now we are finding the, you can say, electric field intensity at any point, that means it will make, say, at an angle, say this is the p point, this is the p point, and it will make an angle theta. So that is the questions, that means PBA point that will be at a distance r from the center of the dipole, and let this OP line that will make an angle, makes an angle theta with the directions of the dipole moment. So now what we can do, we can resolve, you just listen carefully, that we can resolve this P into, say, two components. We are resolving P into two components. So if you can resolve P into two components, what should be the two component? One component it along this particular directions, because what we know, that if we know the vector analysis, then what do you know, that if the vector is speed, so you can say because the vector in that particular case is this direction, this is the p and this is theta, so you can say that direction is p cos theta. Okay, and the perpendicular directions, that means these directions, this perpendicular direction is p sine theta. Is it clear? That means when we write a vector p in this direction, and if you break into two components, then the theta component is p cos theta and the perpendicular component is p sine theta. Okay, so if we break this, if this is a p, because that is a p, you know, and if you break two components, so along these directions is p cos theta, and if we draw the perpendicular directions, this direction is p sine theta. Is it clear? Now what we find, that you just see, this is a p cos theta, this is p cos theta, and you are finding the electric field at point p. Okay, and the distance of, that means that now the dipole is p cos theta instead of p, and this is nothing but the axial positions. This is nothing but the axial positions. If this is the axial positions, then if we find the electric field at that particular point, say E1, that is nothing but, what we find, that is nothing but 2p cos theta by 4 pi epsilon naught r cube. Is it okay? Now if we consider sine component, you just see, this is the p sine theta component, this is the dipole, and you are finding at point p. So this is nothing but, this is the total dipole, which is p sine theta, and we are finding the electric field at point p, that is same as, you can say, the electric field at perpendicular positions. That means you can say at you can say the Bourdon position or equatorial line, and in that particular case we always find, so in place of p we are just placing p sine theta, and that is 4 pi epsilon naught r cube. Is it okay? So the thing is that we will get two field. If you just write the component, you will see that that is the electric field E1, okay, and that is the electric field E2. E2 is due to this p sine theta, because p sine theta is acting like that. So actually if you want to find the resultant electric field, that is nothing but E, and this angle is nothing but 90 degree. So what should be the electric field? You know that the total electric field E can be written as, that is E1 square plus E2 square plus 2E1 E2, that is cos 90. Cos 90 is 0, so you can say it is E1 square plus E2 square. And you know that E1 means what is E1? E1 is nothing but, you can say, 2p cos theta by 4 pi epsilon naught r cube, that is a whole square, and E2 is nothing but, you can say, p sine theta by 4 pi epsilon naught r cube, that is also whole square. And the thing is that so we can take common as p by 4 pi epsilon naught r cube, and within root this is nothing but, you can say, that is 4 cos square theta, and this is nothing but sine square theta. And now we can write like that, this is p by 4 epsilon naught r cube. So we can break like that, 3 cos square theta plus cos square theta plus sine square theta, and we know cos square theta plus sine square theta is equals to 1. So what we can write, p by 4 pi epsilon naught r cube, that is 3 cos square theta plus 1. Okay, so that is the general electric field that we get. That is the general electric field due to the dipole. That means, and of course, what should be the directions? If we want to find the corresponding direction, say we can take that this particular angle is alpha. That means we can say that tan alpha can be written as E2 by E1. Okay,
So
tan alpha. So this is also E2. This is also E2. That portion. This is also E2, because this is E2 means this is also E2, and this is E1. So that's why tan alpha is equals to E2 by E1. Okay, and Okay, so if we write the directions, that is tan alpha is equals to e2 by e1. So e2 is nothing but you can say p sine theta by 4 pi epsilon naught r cube multiplied by 4 pi epsilon naught r cube by 2p cos theta. So if you cancel out this thing, you will get, you can say, half of tan theta. So the direction tan alpha can be written as half of tan theta. Now if you can put the value, that means if the we consider the case, that means if you can say that point p that lies on the axial line, lies on the, you can say, axial line of the dipole, axial line of the dipole, then what you can see, that the value of theta is equals to 0 degree. Now if you can put it, you will get the answer is same as that 4 2p by 4 pi epsilon naught r cube. That is similar as that axial case. And of course the directions, if you find that tan alpha is equals to half of tan 0, that means you can say alpha is equals to 0. Now the case 1, and if we consider case 2, that if you can say point p lies on the, if the point p lies on the, you can say, equatorial, you can say, line of the dipole, that means theta is equals to 90 degree. That means this cos theta equals to cos 90 is equals to 0. Then you can say E is equals to nothing but p by 4 pi epsilon naught r cube. If we put the value into this equation, the cos theta is 0, so it is nothing but p by 4 pi epsilon naught r cube, and of course the value of alpha is equals to 90 degree. So that you can say is the answer. Okay, is it clear?
Yes, sir.
Okay, so the thing is that if we talk about the, you can say, physical significance, if we talk about the physical significance, you can say physical significance of electric dipole, of electric dipole, then what we can say, that we know that there are matter that will consist of molecules, and each molecule is electrically neutral. So the thing is that we can divide it into, you know, that polar molecule and non-polar molecule. That means we know that if the center of mass of positive charges does not coincide with the center of mass of negative charges, then the molecule is said to be polar molecule. You know that what we uh, that say that if the, you can say, center of mass of, you can say, positive charges, center of mass of positive charges, and that is, you can say, protons, that does not, you can say, include, or does not include, no, does not coincide with the center of mass of negative charges. Negative charges means electrons. Then the molecule is said to be polar molecule. Then you can say the molecule, the molecule is, you can say, said to be polar molecule. That you can say about that. And of course you can say, yes.
No, sir, just
Okay, because you can see that water molecule is a polar molecule, because you know that if this is a, you can say, positive hydrogen, and this is also hydrogen, and this is the oxygen, then what you can know, that they have the angle between this is 105. So that means the center of, you can say, the positive does not coincide with the center of the negative. That means that is, you can say, as a polar molecule. NaCl, and also you can treat it as a polar molecule. So electric dipoles are very important for the study of this electric behavior of ionic solutions. So electric dipole is one of the important significance, that electric dipole are very important, you can say, for the study of the electric behavior of ionic solutions. And there are also the concept of known, you can say, non-polar molecules. And of course, in case of, if we consider about the non-polar molecules, that is the same case. That means the center of mass of positive charges that will coincide with the center of mass of negative charges. That means you can say the center of mass of, you can say, positive charges, you can say, that will coincides with the, you can say, center of mass of negative charges in a non-polar molecule, in a, you can say, non-polar molecules. So that is the thing, and that means when we are study the electric behavior of the solutions, that it is one of the important fact that you need to know. Okay, so now in the next thing that we should know, that is when an electric dipole is placed in an external uniform electric field, the next thing is the, you can say, the electric dipole in an, you can say, external uniform electric field. So when we are placing this electric dipole in an external uniform electric field, that means what we can say, the torque on a dipole, that means you can say torque on a dipole in, you can say, in uniform electric field, that is the important concept that you will find also when we discuss rotational motion in class 11. That is also the same torque. So what does it mean? That means that is the uniform electric field. That means this is the corresponding, you can say, the uniform electric field. And say an electric dipole will be placed like that. This is the corresponding electric dipole. Say that is a positive charge and that is a negative charge. So what we know, that when a positive charge, that means the force, that is nothing but QE. We know that electric force is nothing but Q into E. So the force will be acting this directions, that is nothing but a force. And also you can say the negative force, that is also directed along this direction, that is F minus, because this is minus Q. And you can say if it makes angle theta, and that is also, you can say, if we take the electric field, this is also theta. And the distance between the dipole, that we know, that is, you can say, 12. Now the thing is that, and the direction of the dipole is from negative to positive, that is P. So what is the net force? That means the positive, that is plus QV, that will be acting on this direction, and there is minus QV, that is acting on the opposite directions. That means when you can say about the net force, that means the net force on the electric dipole is 0. So what I am saying, that the charges, that is plus Q and minus q, which constituting the, you can say, dipole, that will, you can say, experience equal and opposite equal and opposite forces given by, you can say, qe and minus qe.
Yeah.
And of course the total force, if we consider that, what should be the net force, what should be the net force on the, you can say, electric dipole. So the net force on the electric dipole, if we consider, that is 0, because this is a plus qe and this is a minus qe, that will give you 0. So f net is equals to 0. So the net force on a dipole in a uniform electric field is 0. So what we can say, thus what we can say, the net force on a, you can say, dipole in a uniform electric field, in a uniform electric field, that is equals to 0. Now the thing is that, what will happen, we know from the definition that these two equal and, you can say, these two equal and opposite forces that actually, you can say, acting on the dipole, that will actually constitute constitute a couple, because you know about the definition of couple, that if two equal and opposite forces are acting, then it will create a couple. So what is the effect of this couple? This couple that will be forming, this couple actually tends to rotate the dipole, because that they are, in case of couples, since two equal and opposite forces are acting, that means the translational motion is 0, but there should be some rotational motion, and this couple actually tends to, you can say, rotate the dipole rotate the dipole in the, you can say, clockwise direction, in the clockwise direction. And hence what they want to do, hence actually tries tries to align the, you can say, dipole along the direction of the electric field, along the direction of the electric field, along the direction of the electric field. So what is the definition of torque? The definition of torque is always been fixed. If we consider the definition of torque, that is, you can say, acting on the dipole, and it can be denoted by this sign. This is the torque, that is nothing but, you can say, or you can say, moment of couple, or you can say the definition is nothing but magnitude of either force that should be multiplied by perpendicular distance between two forces. Is it correct? So what is the magnitude of the forces? That is nothing but QE, if we consider about the magnitude. And what should be the perpendicular distance? This is the perpendicular distance. You just see, তোমারটাই খুব আওয়াজ হচ্ছে মনে হয়।
Sir, fan চলছে।
আচ্ছা আচ্ছা। So this is the perpendicular distance. So the perpendicular distance, what should be this perpendicular distance? এটা যদি perpendicular distance হয়, তাহলে perpendicular distance কি লিখতে পারি?
Sir,
এই ট্রায়াঙ্গেলটা নাও, if we take this, we have to find this perpendicular distance. So if we can write sine theta, then this can be written as 2l sine theta, তাই তো? তার মানে আমি কি করতে পারি, এই যে পারপেন্ডিকুলার ডিসটেন্স এখানে কি বসাতে পারি, দ্যাট ইজ 2l sin theta, and what we know, 2ql is nothing but p, that we can write pe sin theta, that is the magnitude of the torque. And if you write in vectorial notations, then it should be p cross e. That means if we can say that the direction of p is this and the direction of, you can say, e is this, then you know that is nothing but perpendicular to the plane consists of p and e, that is nothing but p cross e. Okay, so that is the one of the case that you can think of, that what we can say, that is nothing but, you can say, the torque that is acting on the dipole. And of course, if we say, if the value of theta is equals to 0, then this torque is also pe sin 0, that means 0. That means when the dipole moment that is parallel to the electric field, that no torque acts on the dipole. Okay, so when, what we can say, when this dipole moment, that is p is, you can say, parallel to the, you can say, electric field, parallel to the electric field E, that means no torque acts on the dipole. Okay, and when, if theta is equals to 90 degree, you can say this is pe sin 90, that means pe, that is the maximum value. That means when the dipole moment, this p is perpendicular to the electric field E, the maximum torque acts on the dipole. That's what we can say, that maximum torque that acts on the dipole. Okay, so that you can say, and that is the thing that you should know. So I think it is clearly understandable that what I am trying to say. Okay, the next thing that we will start from the next class, so that will be Gauss's law. Okay, that will be Gauss's law
Sir, the day of this starting
after completion of this, after completion of this. Okay,
ঠিক আছে, বাস।
তার কারণ